Hello, in this lecture we'll be doing some problems of the mole concept and Avogadro's number, and further in future videos also we'll be doing some problems because this requires a lot of practice. Okay, now we actually learned how to convert from the molecular formula. Oh shit, I don't like this. Molecular formula to the mass composition, right? We learn to convert it to mass composition. Now how do we do that? We do it by dividing the mass of the element by the mass of the molecule into 100. We get it as a percentage. You remember doing that, right? Now how the hell do we convert it back? I'm lazy to write it. How the hell do we convert it back? Oops. Okay. How the hell do we convert it back? Mass composition to molecular formula. To find out that, we'll do a problem. Okay, I'll write down a question. Here is let me increase the size. Okay. Here's the question. 75% Hg and 25% of chlorine. What is the compound? Compound. 25% of mercury and 25% of chlorine. What is the compound? That is the question. Okay, how to do such problems? First, since it's given in percentage, and even if we take how many grams, assume some grams, all the assumptions will have the same amount of proportion of Hg and chlorine, otherwise it wouldn't be a compound actually. So we can assume, let's assume that the compound is 100 grams. 100 grams in total. Okay, now we'll have to find how much will 1 mole of mercury weigh. I have to weigh. 1 mole of Hg will weigh the AMU grams. What is the AMU of Hg? Where the hell is Hg? Okay, where is it? Can't find it. Oh my, yeah, here's Hg. 202. That is the atomic mass of mercury. So if 1 mole of mercury is taken, we will have 202 grams, right? Okay, similarly 1 mole of chlorine will be how many grams? What is the atomic mass unit of chlorine? 35. Therefore 1 mole of chlorine will be 35 grams. It's 35, right? Yes, 35 grams. Okay, now how the hell do we find the number of moles in 75 grams of Hg? Now as you know, we said 75% of Hg and 25% of chlorine, so this will naturally be 75 grams in this, right? 75 grams and 25 grams. Okay, number of, I'll do it in another color. number of moles in 75 gram of Hg. Now that will be 75 divided by 202, right? 75 divided by 202. Okay, similarly we need, I'll do it in another color, the number of moles in 25 grams of chlorine, right? That will be 25 25 divided by 35, right? Okay, now I need some space, so we actually don't need these anymore, so I'll take that off and I'll place this above. Okay, now how do I find the ratio between the atoms of Hg and chlorine? You just divide it, right? I mean to find how many how many mercury atom is needed for one chlorine atom. You just divide it, right? Okay, 75 divided by 202 divided by 25 by 35, that is into 35 by 25. This is a simple one. I'll do it here. 3, till that much. Okay, after this I need the calculator, so let me find the calculator. Okay, therefore 3 into 35 divided by 202. You see, it's nearly 0.5. It's nearly, I'll do it in another color. It's nearly 0.5, 0.59 something. So it is almost 1 by 2. So we assume that the ratio between them, that is, what can we infer from this? We can infer from this that for one mercury atom we need 2 chlorine atoms. We just divided them, right? So now that is the compound. We have the compound over here, HgCl2. That is the answer for the question. I'll put it in a box. Oops, I'll have to take it once more. Okay, HgCl2, you can get that from the ratio, right? 1:2. So that's how you do a problem like this, and we'll do some more problems like this in the next videos. Okay, so that's all for this one. Bye. See you in the next one.